Okay. Assalamualaikum and welcome and good morning. Okay, today is 10th of January 2022 and it's already 11:05 a.m. Okay. So for today's class, what I'm going to do is we're going to start to do some final exam questions. And the reason why we want to do that is I want to give you a momentum in understanding the type of flow of questions of how the final exam is going through. So if I don't start today, I don't want you to wait for the last minute. Yeah. So what we're going to do is we're going to do questions that is coming out from the revision kit. Yeah. And these questions that we're going to do is not necessary like you cannot have a perception, oh, this question is we're going to do in the revision kit is going to be in the final exam. Not necessary. It can, it may be, but whatever, the way of how we practice to answer the final exam question can help you to answer in the upcoming final exam questions. Okay, that is what is important, so that we can get the flow and momentum of how the way we want it to be answered. Okay, so that is our main reason. The second reason, these types of questions, whether in the tutorial class, lecture class, or whether in the final exam, are all examples that we can relate for your project. Okay, all right. All you need to do is find a similarity that you see in your daily lives, and you can relate that into your final as or into your project. Okay, so for example, number one, we're gonna go through some what do you call it, a few questions in revision kit. So so you can, guys, you can open your revision kit. Okay, so let's say we open your revision kit. So let's go to this question. Okay, so this question. Okay, so this question. So this question is what we're going to discuss today. Okay, so for this question, okay, number one, this question is a question for using the Newton's second law. However, you can also relate this question into your project and combine it with work energy method, and also impulse. Okay, all right, because the diagram of the question is a standard question. However, you can be creative, and because if you remember your chapter, your project, okay, if you remember, if you look at your project, what is your requirement of your project? Do you remember? Your project is 20%, and the requirement is it must include chapter what? 3, 4, 5. Understand? So what you means is you need to find an example that can relate all these topics together. And what is topic chapter 3, 4, and 5? Do you remember what is topic chapter 3, 4, 5? Let's go back. You remember, guys? Hello.
A plane motion of rigid body.
Ah, okay. So if we go back to our lesson plan, just to go through with you. So chapter 3, okay, let's go back to chapter 3. Chapter 3 is plane motion of rigid body using kinematics of rigid body. Chapter 4 is plane motion of rigid body using Newton's second law. And chapter 5 is plane motion of rigid body using work energy method and impulse. Okay, so what I'm trying to say is chapter 3 is what? Kinematics of rigid body. Chapter 4, what is chapter 4? Can you tell me? Plane motion of rigid body, but uses what? Newton's second law. Remember? And chapter 5 is what? Plane motion of rigid body, but uses what? Work
Work energy method.
and impulse, right?
Yes.
Ah, Momentum method. Okay. So what I'm trying to say is for your project, if you want to get good marks, you have to find a good example that can relate all these three methods. Okay. Now you have to imagine as if you are the lecturer now, and you have to find one practical example or similar things in our daily lives, whereby you need to snap the picture and also draw the free body diagram, and then combine all these three aspects in one project, in one problem that you want to solve. Okay, all right. So, so for today's class, what we're going to do, we're not only going to look at a final exam question, we're also going to relate the topic and see the topic in that final exam question, and make you understand the how to answer it for the exam, and also it can give you an idea for your project also. It's like a win-win situation, eh? Okay, all right. Now let's go to the example that we want to relate today. So this is what we're going to do today. But however, next week we're going to focus on topic vibration. Okay. All right. So that's what we're going to do today. So let's go back to our revision kit. So so if we open back our revision kit, can you go back to the question that I shared just now in the revision kit? If you open your revision kit, we're going to do this question. Okay, now. Okay, this question, okay, just by looking at the diagram, can you relate an example in our daily lives that represent this kind of thing? Can you see what is happening? There are two blocks here. One is block A, 10 kilograms. One is block B, 20 kilograms. Okay, so if block A is going down, block E is going up, and there is a pulley that is holding those two blocks together with a cable, right? What kind of example that you can see in this kind of example? Can anyone give me an example that can they relate in their daily lives?
Lift.
Leaf, yes. So, of course, okay, a leaf. Yeah, that's that's a good example. So maybe the manual type of leaf where there is a pulley that is rotating and is carrying weight. Okay, so obviously, if the leaf, it will not look like this. Maybe if it's a leaf, it will I don't know, maybe something like this lah. Maybe a leaf, macam tu kan? Right? This kind of leaf, maybe this leaf is carrying a basket of fruits ke, kan? Something like that lah. So those are all types of examples that you can relate in our daily lives. And another good example that I can see recently, now since we have COVID, our what do you call that? Since we have COVID, kita rely a lot on Grab food, right? Grab food, and sometimes the person that is ordering Grab is at level 4 block. Perasan tak? Perasan, do you notice sometimes people who order Grab, they are at level 4. And when they are at level 4, orang yang order Grab tu, macam mana dia nak bagi makanan kat level 4 tu sekarang ni? Trend sekarang ni.
Dia letak baldi.
Dia letak baldi kan. So dia letak baldi, dia tarik kan. Tapi ni tarik menggunakan tenaga kan. But if you creative, you ada satu pulley kat sini and then tarik kan. Dengan tension cable T ni kan. Kan, it can also be an example, right? So basically, you have to be creative when you look at this final exam question. How can you relate it into your project? Okay, all right. But at the same time, as I said, where it's going to be a win-win situation, whereby we are not only going to where we're not only going to practice how to solve this problem, but I want you to try to imagine in your daily lives this kind of practical problems that you can put into your project. Okay. So when you discuss in your project, for example, this as example, if you want to relate it, you can relate it. What is the for example, you can relate what is the angular acceleration of this pulley. For example, what is the angular acceleration of this pulley? What is the time taken? What is the time taken for this bucket to reach level 3 or level 4? What is the distance travel of the bucket from level 1 to level 3? If or what is the what do you call displacement, displacement in terms of angle. It can be in terms of angle. So all these examples actually relate to chapter 345, right? Remember, chapter 3 is what? Kinematics of rigid body. And maybe for kinematics rigid body, you want to try to ask what is the speed. So what is the speed? It means they ask you to find what is the omega. Omega is what? Angular velocity. So maybe for this type of example, you want to use the standard formula. Okay. And then if you want to relate time, you need to use what? Impulse. And if you want to use displacement, you want to find the angle. It depends on the question, the type of question. What is question is suitable? Maybe not types. Maybe given angle. Given the angle, maybe this angle is given. This angle is given, and what is the difference in terms of velocity, acceleration, all that. However, what I'm trying to say is you can use work energy also. So let's say I ask you, if you want to use work energy, what do you want to find? Can you tell me? For this type of example, work energy, what is the variable? You want to find the velocity. What else? What else, guys? I want you to tell me. For work energy,
Force and displacement.
pardon?
Force and displacement.
Force. Okay, that is the word. Force and displacement. Okay, maybe you want to find out what is the force required for the person to pull I don't know, a 10 kilogram weight, things like that. But however, your project must consist of all these topics: kinematics of rigid body, and topic plane motion of rigid body, that consists of a method of impulse and work energy. So you have to be creative. This is just one example. There are many, 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 many different types of example. You have to imagine that you are the lecturer. I'm not trying you to imagine that you are the lecturer. Sorry, I'm trying to imagine that you are trying to create a problem to solve. So, and then from this problem, so you don't need to make it too difficult. Maybe you want to differentiate in terms of level. How long does it take to travel from level 1? How long it takes to travel to level 2? How long it takes to level 3? So the time taken for each level, of course, it will be different for each level, right? But however, it will produce a linear graph, right? For each level, kan? Do you understand? The linear graph lah. Maksudnya let's say this is your graph, this is time, let's say this is versus level. For level 1, it takes, I don't know, 3 seconds. Level 2, it takes if it's linear, it will be 6 seconds lah. Contohnya lah. Level 3, you rasa berapa? 9 seconds. So it will show a linear graph, right? Okay. So that's why in your project, we ask you to produce some graph or even bar charts. So you have to be creative. For example, maybe you want to change your variables instead of different levels. Maybe you want to change different weights, 10 kg, 20 kg, 30 kg. When you change these weights, of course, you will get a linear graph also, right? But maybe you want to be creative. Instead of one pulley, maybe you have two pulleys, you know, two ropes, okay, like one rope with a radius. You can what I mean is, you can change the radius of your example. Let's say if you choose radius 0.2, what will be the tension force? If you choose radius, for example, maybe this radius is 0.1 meter, what is the tension force for that one? You know, you want to see the difference. You want to be able to understand what difference will it make in terms of the force, or difference will it make in terms of the time taken, or the velocity taken. So basically this is your purpose of your project. So your project, you have to be able to relate these three topics together, and at the same time produce a problem that you want to solve, and you want to identify what type of output results will make a difference to your equation that you come up with. And then you will discuss, oh, if we change the number of if we change the apa, if we change the weights, the velocity taken, or the time taken to for it to move for one level to another level is different, you know, things like that. Okay, all right, so I hope you have a better idea now on how to do your project. So it's 20%. So so what I want you to do is, I want you to really think a very smart way, a very good example that you can relate all these things. Okay, but but in a way, how you can relate these um examples. Okay, so how you can relate this example in your project is, one way is doing the tutorials that we do in class and the final exam question. So based on doing the tutorials and the final exam question that we discuss during class, kan, you will have a good example of an idea on how to do your project. Okay, all right, do you have any questions in your project before we start doing some final exam questions? So what I'm trying to say is, I don't want you to only think that we're doing this final only for your test too. No, not really. We're doing this final exam so that we can, number one, I want you to have semangat, a momentum to start working hard to do the revision kit and final exam question, and at the same time look at the examples and try to relate in the daily lives that you can see surrounding you for your project. So do you understand the aim of our class today? Do you understand, guys?
Yes.
Okay.
Yes, teacher.
All right. So do you have, so that's why in your project, we give samples of a graph, bar chart. You can also do pie chart. I don't know. It's like something like you need to do a kind of research with your problem. And then from the data results that you have, you explain it in terms of a poster. And then you discuss what makes a difference, what does not make a difference, and how to improve the system. For example, if we add another pulley or reduce the radius, or we increase the force taken, it can help to speed up the process. You know, that is the kind of discussion that I want. That is based on the data that you are able to produce. Okay. Are you okay? So what I want to do is, maybe after this, you have a better idea of your project. You can always text me in the Telegram that I will give you. Is it okay that I do this kind of problem? Is it relevant? Does this make sense? Or is it okay if I do this? If you want to have like a green light from me, um, then you can ask me lah. Sometimes when you have a green light from me about the topic or project that you want to do, you will feel more comfortable to proceed with it. Okay? Is that okay? You can ask me, please start now. The important thing is you have your example ready. And I would like it if your example, you can take pictures, you show the real life picture of the problem. And then, however, even though the real life picture of the problem is not exactly how you want to portray, but something similar is already good enough. But at the same time, you must sketch, draw the free body diagram of how we do in class. Do you understand? Do you understand, class? You not only need to take the picture of the real life problem, and the picture that you take, it can be taken using your handphone, or you can even Google it. If you want to Google it, make sure you put the reference. So you Google a problem in internet, and you want to use this as your project, and at the same time, make sure you sketch. This sketch free body diagram, you have to draw yourself. Draw yourself. I don't like problems that you screenshot from the internet. The free body diagram is also from the internet. You copy paste everything and you put it there. Even the equation also you copy paste. You can write your equation yourself. If you do not know how to you know how to use Word, kan, how to write down the equation using word template, kan. You do use the word template, make it professional, do yourself, no screenshot here, screenshot there. Okay, but an example that you found on the internet, you can take that picture, but draw yourself the free body diagram, sketch it. Okay, if you don't know how to sketch it, you sketch it using word. Maybe sketch it on a piece of paper, and then you redraw it, and then you scan, and then you paste it on your project poster. Okay, any more questions that you would like to ask? Ada? Okay. Right, let me just ask randomly. Nabihan, Nabihan? Nabihan,
Yes, Doktor.
do you already have a project topic?
Belum lagi.
Okay, now belum. Do you know what you want to do? Like, do you have an idea? What are you thinking right now, Nabihan? What do you want to do? You don't have yet, but what are you minat? What do you think you want to do what do you want to propose for your project? What do you think?
Apa ya? Sebab saya untuk short term ni mungkin roda kereta kontrol tu. Tayar kereta kontrol.
I see. So roda lah. So let's
Sebab
say
tu yang ada depan mata saya lah.
I see. So let's say this
Ah.
is, you have a plank and then ada angles ini. So this is your car tire. Yes, you
Ah.
can. So in your car tire, remember topic force and acceleration. Topik yang ni kita ada discuss. So dia ada apa? Of course ada normal force, kan? And then ada weight, kan? So the car tire. So it means there is a car lah. Let's say you have a car lah, kan? So does the car make a difference? Does the force, does the acceleration make a difference when you add weight? When you add weights, faham tak? You can do that. Or with no weight, no additional weight. So it means the weight of the tire will be different, kan? The normal force. So what aspects cause the difference in your problem? So that's where you want to discuss. And then let's say you have friction. Maybe one is sliding down a smooth surface, and the other one is sliding down due to a rough surface, and the friction changes. Maybe one friction is 0.03 and the other friction is 0.02. What difference in the results can come? If the friction is higher, is it give better result? If the friction is If the friction is lower, does it give a better velocity? Things like that. So there are a lot of what you call parameters that you can change in your control car, isn't it, Nabihan?
Yes, ma'am.
Yes. There's a good example that I can give you that I can make you relate. Okay, Nabihan. Nabihan. Okay, let's say we let's say Nabihan, this is you. This is you. Yeah, sorry.
Okay.
Okay, let's say Nabihan. I'm trying to tell you. Okay, let's say this is Nabihan. Okay, ni daripada pandangan depan ya kereta
Okay.
Pandangan depan ya. Pandangan depan. Okay, ni you Nabihan. Okay. Nabihan ni saya. Nabihan, you kereta apa?
Kereta apa Kereta Pro 2.
Alah. Okay. Okay. Nabihan, you nak bagi saya kereta apa?
Kereta Proton lah.
Eish! Saya ambil Range Rover lah. Okay, takkanlah
boleh.
Proton pula. Okay, you Pro 2.
Ah.
Saya naik Range Rover. Okay, kita tengah nak turun bukit ni. Ni daripada pandangan depan Dari pandangan tepi
Okay.
macam ni lah. Dari pandangan tepi macam ni lah. Okay?
Hmm.
Sebab I nak tunjuk gambar. Okay. Anggap, okay, assume Nabihan you dengan I. Okay, ni Nabihan. Okay. So ni saya lah, Yazmin saya naik Range Rover, you naik Pro 2. Okay, kita nak turun bawah bukit ni. Bukit ni dia punya friction, coefficient of friction sama.
Oh.
Okay. Coefficient of friction dia sama. Maksudnya sama di semua tempat. Sama di semua tempat ni. Okay, assume lah. Tapi in reality, jalan yang betul taklah kan. Okay, jalan raya yang betul taklah. Tapi untuk sains, sekarang ni kita assume coefficient friction kita sama. Kita turun bukit ni. Okay, alright. So sekarang ni, you dengan saya tengah turun di bawah bukit ni. Okay, naik kereta ni, kita tengah release handbrake tau. Kita dua-dua tengah release, kita tengah angkat handbrake, lepas tu kita release serentak. You rasa siapa turun lagi cepat? Saya yang naik Range Rover ni ke? You yang naik Pro 2 ni? Tapi sebelum tu, kita punya tayar punya friction ni pun sama. Maksudnya kita punya perbuatan tayar ni diperbuat daripada kilang yang sama. Tayar kita ni, faham tak? Kita bukanlah Range Rover ni pergi overseas, you Pro 2 local, tak. Assume kita punya tayar ni, kita punya ring tayar ni pun sama, faham tak? Dia punya perbuatan dia. Ring tayar ni, dia punya friction ni sama, jalan ni pun sama. Okay, sekarang ni, saya dengan you tengah turun bukit ni, bersama, kita tengah angkat handbrake ni, lepas tu kita release serentak. Siapa sampai dulu?
Tengok weight tu.
I nak tanya you cuba jawab dulu.
Tengok weight berat.
Jadi, kalau tengok weight, apa yang berlaku?
Yang ringan akan sampai dulu.
Yang ringan akan sampai dulu. So, you nak cakap you menang lah. Race ni lah.
Saya yang berat.
Pro 2 dengan Range Rover, yang mana lagi berat? Yang mana lagi
Range Rover
berat?
berat.
So, siapa sampai dulu?
Doktor.
Saya sampai dulu.
Tak. Saya.
Kenapa you sampai dulu?
Yep.
Sebab apa?
Force dia kurang. Yep.
Ah.
Force dia tinggi kot.
Ya, I nak bagi tahu sesuatu. Okay. Jawapannya, kita akan berdua sampai serentak. Sebab sekarang ni, kita punya tayar punya friction sama. Kita punya coefficient friction jalan tu sama. Tak kisahlah seorang tu lebih berat ke apa. Disebabkan friction dia sama, kita akan sampai masa yang serentak. Yang akan membezakan kita jika friction kita berbeza. Jika tayar kita punya friction yang berbeza. So macam mana you nak tahu? You kena buktikan dengan calculation you. Bahawa weight does not make a difference in your results. The thing that will make the difference in your result is actually the Friction. The
Friction.
smooth of the road. You understand? So inilah benda yang you nak tunjukkan. So dia ada satu dia macam ni lah. Macam let's say ni kan jalan, let's say lah you ada satu kotak ni. Kalau bukan kereta lah, tadi saya nak bagi example kereta gempak sikit. Okay, let's say dua kotak ni diperbuat daripada material yang sama, friction ni pun sama, tapi kotak A ni kosong, kotak B ni kita letak pemberat, kan? Bila kita release serentak, dia akan sampai waktu yang sama. Sebab friction jalan dia sama dan friction antara permukaan kotak tu dengan ni pun sama dan dia pun buat daripada sama. Tapi in reality kalau kita buat real eksperimen, dia tak sama lah, sebab kadang-kadang surface ni adalah tak smooth, dia ada dia punya friction tu tak sama, faham tak? Faham? And then yang dia material yang dia buat box ni mungkin pun tak sama. Mungkin adalah kasar sana, lembut sana, kan, dia tak sama. Tapi in reality dia kalau you buat eksperimen yang betul-betul, sebenarnya dia akan sampai almost the same time. Walaupun ni ada berat. Tapi macam mana you nak tunjukkan tu, you kena tunjukkan dari segi calculation lah. Faham?
Faham betul.
Okay. Alright. Ini example ni ada satu profesor physics lah yang famous tu. Dia ada buat example ni. Dekat YouTube ada satu example ni. Dia nak cuba buktikan bahawa you akan sampai masa yang serentak. Tapi of course lah ada plus minus lah. Beza sedikit je lah. Sebab in reality kita tak boleh lah anggap sepanjang tu dia sama lah kan. Tapi kalau based on calculation, kalau anggaplah jalan tu perfect, sama, dia akan sampai serentak. Tapi itulah, so that's why you kena tunjukkan melalui calculation apa you dapat. So mungkin dari situlah yang berperasan. Rupanya the weight does not play a role in the time, the equation of time. Okay? Boleh?
Ya, doktor.
Okay, so good that you understand this. So, tapi I tengah try to make you more creative lah, think of the problem. Tapi projek ni jangan ngambil masa yang terlalu banyak. Once you get your problem that you want to solve and you understand what you want to do, then you can proceed with your project lah. Okay, but you must be creative lah in thinking ways and methods to do this lah. Okay, so since we're talking about project, let me just give you another good example, something similar like this. Okay, similar like this. Okay, Nabihan, since sekarang ni you dengan I lah. Nabihan, you besar ke kecil? You berapa kilo?
Saya dalam 58.
Allah, so saya ni 3 digit, saya ni double lah. Okay, Nabihan, ni dekat mana ni? Kita dekat mana sekarang?
Kat playground.
Okay, kita kat playground So ni Nabihan ni you. Ni saya lah, pakai tudung kan. Okay, kita kat playground. Okay, alright, so kita tengah naik apa ni? Ni apa? Swing. Okay. Alright, ini related dengan topik vibration You all belum belajar lagi Tapi sebab I just nak bagi satu contoh example untuk bagi you ada idea. Okay, Nabihan, you 50 kilo. Okay, saya 3 digit, so saya 100 kilo. Okay, kita dua-dua tengah naik swing. Okay, so kalau daripada pandangan tepi, let's say kita tengah naik swing dan kita berdua akan ditolak dekat satu angle yang sama lah. Tak tahu, rambut you kerinting kot Nabihan. Okay, so you akan ditolak ni swing ni. Okay, now alright. So bila you ditolak swing ni, okay, I nak tanya Nabihan, you dengan saya, bila kita naik swing ni, kita akan ditolak ke depan and then kita akan patah balik kan, satu cycle kan. Okay, anggaplah ni satu cycle, time taken. Okay, siapa yang untuk satu cycle dia ke depan dan then patah balik macam ni, siapa yang akan lebih cepat sampai time taken?
Saya
Sebab you lebih ringan. Sebab apa?
eh,
Sebab apa?
mungkin tak
Sebab apa?
tak ada friction apa semua tu.
So, tak ada friction semua, you juga nak menang. You juga, you akan sampai dulu. Ha? Saya tak. Saya slow sebab saya berat. Rasanya,
Danger.
macam mana Nabihan? Ha.
Cubalah doktor.
Okay, tak apa. Kita tak belajar lagi topik ni. Tapi just saya nak bagi tahu you all, semua yang mendengar, walaupun Nabihan dengan saya dan saya lebih berat, tapi dengan assume kita dekat angle yang sama, ni macam, anggaplah macam pendulum kan? Pendulum kan? Dia macam pusing macam tu kan? Antara saya dengan you, kita akan sampai pada masa yang kita akan mengambil masa time cycle taken ni akan sama. Maksudnya untuk Nabihan dengan saya, Dr. Yasmin, kita akan sama. Sebab untuk equation vibration, yang menyebabkan perbezaan bukan berat kita, tapi sebenarnya panjang tali tu. Understand? Okay? Sebenarnya kalau you ada satu pendulum macam ni kan? Pendulum tu faham kan? Macam ada rantai ke ni kabel ni. Kabel, anggaplah ni pemberat tu lah kan? Kan? Yang membezakannya adalah panjang ni, length ni. Faham tak? So, yang membezakan untuk time taken, ni time taken for you to swing back and forth ni, yang make a difference is actually the length of the cable, not the weight. So, kalau you ada pemberat yang sama macam ni, pemberat yang sama tapi length dia berbeza, the time taken will be different. Faham tak? Yang ni different, tak sama. Tapi ni time taken ni akan sama. Tapi untuk ni, because the length is different, let's say ni L2, ni L1 ni pendek, L2 ni panjang, the time taken is not the same. Time taken untuk length T2 dengan T1 ni tak sama. Because what makes the difference is the length of the cable. So kalau kita dua-dua sekarang ni, kita pergi padang permainan, I dengan you, kita lawan swing tu, siapa yang sampai lagi laju, sebenarnya kita akan sampai serentak. Tak kisahlah weight. Tapi yang membezakan apa Nabihan?
Panjang kali.
Sebab dalam equation pendulum, the length is what is important. Understand?
Betul.
Okay. So, dalam topik sebenarnya dinamik ni, untuk topik project ni, what we want you to be able to explore and understand is discuss this kind of problems lah. What makes a difference in the variables, in your data results, and how you can discuss the problem, and at the same time, how you can make it better. Faham tak? At the same time, how you can make your problems better also. And jangan lupa, you kena relate dengan SDG. Ini you kena baca dulu. You kena baca apa tu Sustainable Development Goal, itu apa, and you kena relate. Macam mana nak relate, kita tak akan discuss sekarang ni. You kena baca dulu apa tu Sustainable Development Goal, dan baru you boleh tulis. Okay, baru you boleh discuss dengan saya. Kalau you tak baca, then susahlah, bacalah dulu. Fahamkan dulu. Okay, so that is your project. So all this information, all you need to do is produce it in one poster presentation lah. Dan pensyarah boleh bezakan student yang copy paste kat internet dengan student yang betul-betul buat kajian dan analisis benda ni sendiri. Bila dia copy paste kat internet, tak apa-apa dia tulis. Dia paste, benda tu tak relate pun, tak ada kaitan pun, tak ada kesinambungan pun, tak ada dia punya logical sense pun. So, that's why this project you kena do yourself. You kena do by your heart. You kena explore the problem by your heart. Okay. Alright guys, so inilah maksudnya lah projek yang kreatif, yang menarik, yang you boleh explore, show the difference, faham? Okay, but based on your equation tu, you akan buktikan bahawa output yang you dapat tu macam mana. Okay, so are you okay guys? This is your project, Okay? Boleh?
Betul.
Okay, alright. So now since this is about your project, maybe now we can start to do some questions lah. Okay, now let's do this question. Where is the question? Okay, this question. Okay, this question is already in the revision kit. So I will read the question. So what I want you to do is copy this draw this diagram in your book lah. Okay, so draw the diagram in your book. Okay, I will read the question. Figure question 4B shows a double inclined plane supported by two blocks. So there's two blocks here. Those blocks are unequal mass, 10 kilograms and 20 kilograms. The mass of block A is 10 kilogram and the mass of block B is 20 kilogram. Okay, now obviously you tengok ni 10, ni 20. Adakah you boleh terus anggap blok B yang akan turun ke bawah? Adakah itu apa yang you fikir dari segi logical sense? Kemungkinan kan? Tapi
Yes.
tak semestinya. Sebab mungkin tension of the cable is different. Kalau tension of the cable is different, maybe walaupun block A is heavier, is lighter, it can be that block A is pulling it down. Tapi bila kita buat research, kita tak boleh terus assume mestilah block B yang akan turun bawah, dia lagi berat. Kita in engineering, kita kena show and prove through calculation. Betul, block B yang akan ke bawah. Tapi kita kena show. Faham tak? Kita kena prove and show that will happen in our calculation. Itulah civil engineering, itulah research. Dia sama juga macam ni. Let's say you duduk dekat kerusi, kerusi you kan ada 4 kaki kan? Ada 4 kolom kan? Hello? Faham tak? Ada 4 kolom kerusi. Kerusi ada berapa kolom? 4 kan?
Right.
Okay. Let's say lah you duduk kat kerusi tu sekarang ni. Okay. Let's say you duduk kat kerusi sekarang ni. Tiba-tiba salah satu kaki dia kerusi tu patah. Apa jadi kat you? Apa jadi kat you? Jatuh. Tapi kalau dalam engineering, kita kena buktikan kenapa benda tu akan jatuh. Kenapa bangunan tu, kenapa atap bangunan tu, kenapa rumah tu akan jatuh kalau satu kolom tu tak ada. Faham tak? Kita in research, kita kena prove it. Kita tak boleh assume. Jatuhlah. Mestilah ke kanan, mestilah ke kiri. Itu cakap kosong namanya. Kita tak boleh. Kita kena show proof in terms of calculation. Kita have to have a justification. If the one of the leg is broken, it will lead to the collapse. You yang akan collapse. You yang akan jatuh. Things like that. So macam ni, sample macam ni, you tak, macam tadi lah. Macam tadi. Mana tadi Nabihan you dengan saya? Ni kan, kita kan kat buayan tadi kan Nabihan? You terus assume sebab you ringan, you terus cakap sebab I ringan, I akan sampai lagi laju, lagi cepat. Tak semestinya. Faham tak? You kena tunjuk and prove in terms of calculation. Rupanya bila you prove in terms of calculation, kita sampai pada waktu yang sama. Tapi yang membezakan sebenarnya adalah panjang tali tu. Faham tak? This is what you call research. You have to prove in terms of research of your data and findings what you get based on the fundamental concept. Okay? Alright? Okay. Now go back to here. Okay. I hope I have inspired you to get a better idea and understanding on how to do your project. And at the same time, we're going to do this example. Okay. All right. So go back to this example. So, okay. The pulley C has a mass of 6 kg and the radius of gyration is 200 mm. Okay. The system is then released from rest. Okay, using Newton's second law, express the equation of motion. Okay, now kita draw dulu diagram ni in our problem. Okay, let's do this diagram. Let's draw. Are you drawing, guys? Can you please draw? Okay. And when you draw also make proper sense lah. Kalau this is block A is 10 kg and block B is 20 kg, in your diagram draw lah 20 kg besar lagi. Dia kena ada common sense lah. Sometimes kadang-kadang kita take for granted these things. Sometimes I also take for granted. So ni. Now, untuk soalan ni, revision kit ni dah ada jawapan dekat dalam answer booklet tu lah, tapi saya tak pastilah jawapan tu ikut apa sebab ada confusion sikit dengan soalan ni. Sekarang ni untuk soalan ni anggaplah radius pulley ni adalah 0.2 meter. So tadi kelas pagi tadi yang sedang tengok video ni, saya nak fixkan radius ni adalah 0.2 meter, tapi radius of gyration adalah 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 200 meter lah, 200 mm lah. So siapa yang join kelas pagi tadi, saya rasa ada sedikit confusion dengan value ni. So untuk soalan ni kita fix value ni radius of pulley 0.2 meter, radius of gyration 200 mm. So kita akan recalculate dan akan ada jawapan baru untuk soalan ni. So ni kita akan ambil radius of pulley. So siapa tengok kelas pagi tadi, saya tak follow this thing lah. Tapi it's okay, kita dah jawab dah soalan tu tadi dan whatever jawapan yang kita discuss that morning is correct lah. Okay, but however for this class, I want it fixed to be like this lah. Okay, so now what is the weight of block A? 10 kilogram And what is the weight of block B? 20 kilogram Okay, all right, and then okay, this is C okay, and the angle here sama 45 degrees. Okay, now so let's solve this problem together Okay, now untuk soalan pertama, okay, the question number 1 is write the equation of motion. So dia nak equation of motion. Okay, so for equation of motion, of course, you're going to draw a free body diagram lah. So kita akan draw a free body diagram. Of course, tak cantik. Make sure you draw a straight line ke bawah, weight, and then you akan ada normal force. And untuk soalan ni ada friction tak? Ada tak? Kelas? Ada friction tak? Senyap je?
Tak ada.
Tak ada. Okay. Alright. And then kita ada tension of the cable. How do you draw the tension of the cable? Let's say this is your joint A ni, dia kena pulling the joint. So kita pull. Nampak ni joint A ni. Oops. So kalau you nak with tension of the cable, pulling the joint. Pulling. So dia macam ni. Faham tak? This is how you draw the tension of the cable. Okay. So if you confuse macam mana you nak draw tension of the cable. So this is joint B, dia kena pull. Sekejap kacau amat. Habis sana amat. Go. Okay. Alright. So pulling the joint kadang-kadang tension of the cable ni pun sudah boleh buat je. So pulling the joint. Okay. T2. Okay, pulling the joint So dia pull. This is the joint. So kat sini this is the joint. Okay. This is the joint contohnya. So dia pulling So block B pun akan ada weight ke bawah. So make sure you draw. Ni pun ada normal force. So semua ni free body diagram ni kena ada dalam drawing you. And also when you do your project also must be in your drawing of your project. Okay. You kena faham your lecturer will be marking your project. Dia akan senang mark, oh this person draw free body diagram, dapat markah. Oh this person draw free body diagram betul, lagi dapat markah. Betul dan betul, faham tak? So you kena be smart in way of thinking of how to grab your lecturer punya attention in getting the marks. Okay, alright, so this is the correct free body diagram, but of course now the axis. Now, axis let's say sekarang ni kita assume saja, assume. Whatever kita assume ni, if kita dapat negatif, maksudnya assumption yang kita telah buat tu salah. Okay, so let's assume our block is moving down. So if our block A is moving down, what will happen to block B?
Gerak ke atas.
Okay, so if block A is moving down, maksudnya acceleration moving down, so you assume this will be your direction for your XY axis lah untuk block A. Okay, and then your block B is moving up, right? So your direction must be like this. Nampak tak? Your direction of XY axis untuk block B, this is for block B, must be like this. If you buat block B macam ni salah. Because now you have assumed block A is going down. So when you assume block A is going down, positive, your block B is going up. So when your block B is going up, the direction of X positive must be like this. Understand? This is no. This is no. This is yes. Okay? Boleh? Ke you ketawa? I cakap no. See you ketawa, I tahu. You tengah ketawa kat I cara I cakap no kan? Okay. Boleh tak? Do you understand? Okay, now. So, since your direction X and Y, you dah determine macam ni. So, you have to make sure all your direction must be in the XY direction. Now, obviously, your weight is not in the XY direction. So, what do you need to do with your weight? Class?
Kena
What do you
resolve.
need? Yes, you need to resolve. So when you resolve, dia ke bawah macam ni, dia turun ke bawah macam ni, mestilah macam ni. Betul tak? Bila dia ke bawah macam ni, dia mesti macam ni dan macam ni. The direction must be correct. Ada student juga, dia buat macam ni. Apa jadi tu? Alamak. Okay. Ada juga student yang tersilap, dia buat macam ni. Betul ke salah ni? Ni. Betul ke salah ni?
Salah.
Salah. Okay. Sekarang salah lah. Tiba-tiba masa exam ada juga yang buat macam tu. Rasa cekik-cekik. Okay. Tapi janganlah. So you must make sure the direction is correct. So this will be W sin theta. This one will be W cos theta. This one will be W cos theta. This one will be W sin theta. Okay. W tu jangan lupa. W adalah mg. So m 10 times 9.81 lah. So ni akan dapat 98 lah. 0.1. And ni pula 20 times 9.81. Berapa? Nine 6.2 Newton. Okay. Alright. So this is the correct free body diagram lah. So whatever problems that you have for your project, also you must make sure you draw the correct free body diagram lah. So problem number 1, dia suruh write down the equation of motion. Tapi does it mention what method in the question? What method can you see here? Using what method?
Newton's second law.
Okay. So Newton's second law. Let's go back to this one. So let's use Newton's second law. What is Newton's second law? F equals to MA. Okay. Now, okay. Tadi mungkin terlupa nak mention dalam kelas sebelum ni. So, siapa student yang tengok video ni, make sure you write equation F equals to MA, and also don't forget my for my previous class student, draw the direction. Positif ke bawah. Okay. But before this, sebenarnya there is actually one more important equation. Maybe I rarely mention, but you will get marks. Tu macam ni. Summation forces Fx ialah summation Fx effective. Okay, and then you do F equals to MA. Okay, so if we do F equals to MA, now because there are two blocks that now the thing that is causing motion is the blocks, kan? So you need to write the equation for block, those two blocks lah. So we do for block A first lah. So kalau for block A positif ke bawah, you akan ada apa? W sin theta minus T, betul tak? Equals to M A. Betul tak? Class? Am I right or wrong? Okay, so 10 times 9.81 times sin 45 minus T2 mass dia 10. Now, acceleration kat sini, because we're topic rigid body, formula acceleration ialah R alpha. Okay, what is our R for this question?
0.2.
0.2. Okay, untuk kelas tadi, pagi tadi, kita terassume R to be 0.02. Okay, tapi it's okay, doesn't matter. Whatever answer you got this morning is correct. For this class, kita assume 0.2. Alright. What is important is the correct method you solve it. Okay, so 0.2 so acceleration is R is 0.2 kali alpha lah. Okay, so alpha adalah alpha adalah apa? Angular acceleration. Okay, kalau you lupa lah. Okay, so if we simplify this formula, what you get? 10 times 9.81 times sin 45 dapat apa? Did you get same as me? 69.367 minus T2 equals to 2 alpha. So, sorry, kenapa saya tulis T2? You all tak betul kan? It should be what?
T1.
T1 equals to kalau T1 bawa sebelah, so 69.367 minus 2 alpha. So this is the Q equation. You must look at the question. The question is, using Newton's second law, express the equation of motion of the blocks and the pulley. So maksudnya for this question, dia nak equation of motion of the blocks and pulley. Now, you baru buat untuk block A. So, this is the equation of motion for block A using Newton's second law. So, class, boleh tak you do for block B? Supposingly, you get it right. Okay, I'm going to call siapa kat sini. Maisara.
Ya, Doktor.
Can you give me the equation for block B?
Negative W sin theta.
Okay.
Plus T3.
Dari mana datang 3?
Saya letak T3 untuk yang block B tu. Oh, letak T2. Plus T2.
Lagi?
Equals to MA.
Okay. So that is your equation for block B. Okay, so write down. Okay, I always advise my students, okay, if boleh during exam purpose, tulislah dalam bentuk simbol ni dulu. Okay, baru you ganti. Okay, sebab sometimes student ni, dia tulis dalam simbol dah betul dah. Tiba-tiba dia ganti salah. Tapi I nampak you tahu tu betul. Tapi adalah silap. Tiba-tiba kat sini ada negative 9.81. I pun tak tahulah kenapa you all tiba-tiba letak negatif kat 9.81 ni. Tapi saya dah nampak dia dah betul dah. Saya akan bagi markah kat sini lah. Kat sini hilanglah markah dia. Tapi kalau you buat ini saja, lagilah kosong. Tapi kalau you buat atas ni, yang equation ni, at least you dapat markah. Faham tak? Okay? Okay. Maisara, apa yang kita tertinggal dekat block B equation ni sebelum negative W sin theta ni? Apa you tertinggal? Maisara? Maisara kan tadi? Apa nama you? Apa you tertinggal? Ni. Ni.
Oh, dia punya.
Apa tu? F
Dia punya
F equals to MA. You tertinggal ni.
assumption.
Assumption ni penting sebab nanti kan kita ada berapa ramai student. Ada student buat assumption ni, ada student buat assumption ni. Sometimes kalau you share apa problem dengan assumption you, apa assumption you buat, pensyarah kadang-kadang boleh detect, oh sebenarnya pelajar ni dah buat betul tapi dari awal dia punya assumption salah. So mungkin dia nak minus mark kat assumption je. Tapi ni you tak share, pensyarah pun makin banyak. You dah buat salah dari awal, dia kosong-kosong-kosong. Faham tak? Kita tak nak tu. Make sure you tulis assumption tu. Okay. So kalau kita simplify Maisara, terus bagi tahu I equation T tu apa? Saya malas nak buat. Terus bagi tahu saya T2 equals to
Itu equals to MA plus W sin theta.
tak nak. Saya nak value.
Oh, nak value.
Saya nak terus value.
Saya dah kira.
Cepat. Mai. Okay, so student class yang pagi tadi situ, saya minta you all masih tengah tengok video ni Make sure you all tengok video ni sampai habis Saya cakap dengan group lain. Saya harap group lain tengoklah video ni kan. You all sekarang ni dah tengok okey lah. Dah okey lah. Berapa, Mai?
For 4 alpha plus 138.73.
Okay, buatlah 138.73 dulu. Barulah cantik. Pas 4 alpha. Okay. Okay. Alright. So, kalau you tengok balik the question. Okay. Kita dah habis jawab ke? Mana? Using Newton's second law, express the equation of motion for the blocks and the pulley. So, there is one more. You need to write the equation for what? The pulley. So, how do you write the equation for the pulley? Okay, pulley pula. Pulley, of course, you kena take moment effective lah. Take moment effective ni dekat point mana? Point C lah. So then you kena buat assumption. Let's say kita guna clockwise positive. So when you take moment effective, ingat tak apa formula moment? M equals to I multiply by? Ingat tak ni guys? Good. Alpha Okay. So apa? So you all, kalau I cadangkan you all lukis kat sini. Ni T1. Allah, tak cantik tu lukisan saya ni. Ke bulat. Okay. Ni apa? Okay. Alright. Okay. Now. So, take moment. So, kita ada kalau sekarang ni anti-clockwise. Anti-clockwise adalah positif. So, anti-clockwise adalah nak anti-clockwise ke clockwise Okay. So, equation kita macam mana? Kelas T1 kali 0.2 minus T2 kali 0.2 equals to I alpha. So, cari I you nak pakai macam mana? I adalah moment of inertia of the pulley. So untuk ini moment of inertia of the pulley, sekarang ni kita nak guna formula moment inertia of the pulley, kita nak guna apa?
IDs yang MK.
IDs MK. Okay, tahu pun. So MK ke MK squared? MK ke MK squared? Itulah. Walaupun I tak dengar you all duk belik-belik buku kertas you kan, I boleh bayangkan lah. Kalau you all semua buka mic, mulalah belik MK ke MK square kan? Okay. So, berapa mass of the pulley?
6 kilogram.
So, K dia berapa? So, kalau tukar meter?
0.2.
So, berapa K you? Berapa K pula? Berapa I you?
0.24
0.2.
kilogram per meter square. Kilogram meter square. 0.
Okay. Alright. Now. So, T1, T2, 0.24 kali alpha. Okay. Alright. So, ini adalah our third equation. Sebenarnya you dah menjawab soalan nombor 1 lah. Write the equation lah. Okay. Now, cuba tengok soalan seterusnya. Solve the equation of motion of the angular acceleration of the pulley. So, dia nak angular acceleration of the pulley. So, dia nak alpha. So, macam mana kita nak dapatkan alpha ni? You all rasa?
Substitute 1 dengan 2 dalam 3.
Betul. Substitute 1 dengan 2 dalam 3. Okay. Untuk dapatkan alpha. Okay. Cuba buat sekarang bagi I jawapan alpha. Ashraf Haziq. Are you there, Ashraf Haziq?
Saya.
Bagi saya jawapan alpha.
Sekejap dah.
Dah, Ashraf.
Negatif 9.64.
Okay. Negatif 9.64. Unit, Ashraf. 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 Sekejap. Ashraf. You jangan sekejap. Ini adalah angular acceleration. You jangan cakap sekejap. Jangan lari. Apa unit angular acceleration, Ashraf? My God. Ashraf. Where are you? Ashraf. Ashraf. Ashraf.
Rate over per second square.
Ya Allah, Ashraf. Kenapa kena sekejap? Kenapa you kena hilang untuk dapatkan unit ni? Ashraf. You jangan buat I nangis, Ashraf. I rasa dah keluar setitik air mata dah. Okay, patutnya you tahu by heart, Ashraf. Ashraf, tadi you pergi belik buku you ke cari unit angular acceleration ke? Ashraf.
Maybe.
Maybe? Tak ada maybe. Yalah tu, Ashraf. Kalau lah I dapat jumpa you depan mata sekarang ni. Dah rotan dah, Ashraf. Jangan buat macam tu lagi ya, Ashraf. Ashraf, apa unit omega?
Rate over second.
Omega tu apa?
Angular velocity.
Okay. Apa unit theta?
Rad.
Macam mana radian nak tukar ke angle?
Darab under 80 pi.
Okay, nasib baik. Okay. Alright, Ashraf. Okay. Ashraf. Okay.
Tadi terblank sikit ada.
Hey, jangan buat macam tu lagi. Okay, tak apa. Saya pun tutup kamera kan. Tak nampak reaction muka saya. Kalau you boleh tengok reaction muka saya. Okay, alright. Where are we mana. Okay, next question. So, you dah jawab. Tadi 5 markah tau nak tulis equation tu. Lepas tu 3 markah untuk calculate acceleration. Next ialah calculate acceleration pula. Tadi angular acceleration. Now acceleration. Okay. Apa formula tadi? A equals to, ni soalan nombor 3 pula A equals to R alpha. Okay. Alpha kita dah dapat kan? So boleh tak kita calculate acceleration of the blocks? So R adalah radius 0.2, alpha adalah 9.64. So apakah kita punya acceleration of block A?
1.93.
Unit. Siapa jawab tadi tu? Orang yang sama bagi unit. Hello.
Meter per second.
Meter per second square. Okay, alright. So, apa you rasa acceleration untuk block B? Sama lah kan? So, acceleration of block B sama. Jangan lupa negatif. Ada negatif ni. Okay, negatif 1.93 meter per second square. Alright, so it means the acceleration is negative. Okay, alright, next. Solve the speed of block A after after t equals to 8 second. So dia nak speed of block A. So macam mana nak buat? So untuk the soalan speed of block A, very simple. Kita boleh use equation kinematics ni, omega equals to omega naught plus alpha t. Now, omega naught sama dengan apa? Kosong. Kenapa? Dalam soalan dia kata dia start from apa guys?
Rest.
Okay. So dia nak speed, so kita kena cari omega. Alpha kita dah dapat tadi. Alpha kita dapat apa alpha? Negatif 9 dah. 0.64. Time 8. So dapat berapa? Omega dapat apa?
Negatif 77.12.
Negatif 70?
77.
Yalah, unit.
0.12 radian per second.
Kenapa I punya ni tak bergerak? I punya apa ni? I punya pen ni dah merajuk dengan I lah. Kenapa pen I ni merajuk? Okay dah. 77 radian per second. Okay, so tu jawapannya 77 So itu answer je dan 3 marks. Okay, nampak tak? Bayangkan ni 3 marks. Ni satu, ni satu, ni satu. Tu cara you dapat markah. Lepas tu, ini acceleration ni, sebab ni satu, ni satu. Tu markah. Tu cara kita tanda lah. 2 markah, ni 3 markah. Apa lagi? You nak solve problem ni. Solve problem ni, you dapat acceleration ni 1 markah. Apa lagi? Lagi 2, mungkin bila you buat jalan kerja tu, you dapat lagi 2 markah lah, total 3. Lepas tu 5 markah ni datang dari mana? 5 markah of course akan datang daripada equation ni. Equation equation you buat F equals to MA ni akan dapat 1 markah. You buat equation ni 2, ni 3, ni 4 dapat 1 markah. 1, 2, 3, 4 and then free body diagram 1 markah. Okay. Memanglah sedih buat penat-penat free body diagram ni 1 markah je ke? Ya. Tapi kalau tak buat langsung kosong. Salah lagilah kosong. Okay. Alright. So 1, 2, 3, 4, 5. So kalau you buat semua ni akan dapat markah penuh lah. Okay. Alright. So basically so this is so untuk problem yang ini, you rasa untuk problem yang sama ni boleh tak kita buat soalan berbentuk menggunakan okay. Untuk problem yang macam ni, you rasa boleh tak kita buat soalan yang sama berbentuk work and energy dengan impulse? Boleh ke tak? Okay. Boleh tak Kak? Boleh ke tidak? Saya nak tanyalah. Okay. Amirul Iman. Amirul Iman, are you here?
Yeah.
Okay. Untuk soalan ni, okay, boleh tak kita buat soalan ni problem untuk work and energy?
Work energy
Work energy apa? Basically you nak solve problem related to apa? Force? Lagi? Velocity? Lagi? Displacement. Betul tak? Impulse apa? Impulse
Ada
apa?
time.
Force, velocity
Time.
and time. You rasa untuk soalan yang sama ni, boleh tak kita tanya using work energy method, calculate the displacement of block A. Boleh tak? Boleh tak? Boleh kan?
Boleh.
Boleh kan? Boleh kan? Dan untuk soalan yang sama, menggunakan impulse and momentum, using impulse and momentum method, calculate the time taken the time taken for ataupun using impulse and momentum method, calculate the speed of block A for time at time it reach at 8 seconds. Boleh tak? Boleh kan?
Boleh.
So untuk soalan yang sama macam ni, boleh juga ditanya topik work energy dengan impulse and momentum. So untuk you punya project, you gonna be able to read kan untuk problem sama menggunakan apa yang saya cakap tadi? Mana pasal project tadi? Ni. Amirul Iman, kita kata tadi project you kena relate topik apa? Topik chapter 3, 4 and 5. Betul tak? So basically untuk problem ni, yang problem tadi you kena be able to relate untuk soalan work energy dengan time. Okay, saya nak try testing Amirul. You nak kembangkan soalan ni menggunakan work energy. Cuba you draft satu soalan untuk saya. Menggunakan problem.
Guna mana-mana method lah. Work energy dengan impulse tu.
Tapi saya sekarang ni tanya untuk work energy. Cuba you draft satu soalan untuk saya.
Draft soalan
Untuk menggunakan soalan ni. Tadi saya dah sebut dah soalan tu. Contoh dah. Tapi saya nak you yang cakap sendiri menggunakan suara you yang manis tu. Cepat.
Ada manis. Sekejap. Fikir lah.
Cakaplah using work energy method. Contohnya, apa
Using
yang work energy method, apa you boleh buat?
work
Ah.
energy method,
Determine what?
calculate the
Hmm.
displacement of
Ah.
block B
Of block B. Okay, boleh? Of block B. So dia calculate the displacement of
the rest.
okay. So starting from rest. So if you nak gunakan work energy method, you kena pakai principle of work energy. Apa formula principle of work energy? Amirul Iman? Ingat tak? Principle, ingat tak?
T plus U.
Itu suara lain je. Principle of work energy. Amirul Iman, apa formula dia?
Lupa yang Medan cari tak?
Saya nangis. Amirul Iman, last week. You tak ada ke kelas last week?
Ada.
Last 2 weeks? Apa principle of work energy? Formula dia.
Saya tak jumpa nota tu.
Saya tak ajar bagus ke? Dah lah you all pergilah kelas Dr. Aizam. Tak naklah kawan dah dengan Amirul Iman. Betul ke ni? Tak tahu
Oh,
ke?
ada. Ingat. Yang
Apa?
T1
Plus?
plus U1 tolak 2 sama dengan T2.
Work. Betul. Ni adalah principle of work energy. Dan T1 ni adalah apa? Kinetic energy kan? Apa
Ya.
formula kinetic energy? Apa? 1/2? You ni buat I betul-betul nangis lah. Amirul Iman, you jangan buat macam ni. Nanti I kejar you.
1/2 MV square.
Ada lagi satu.
Yang ada
Plus?
impas.
Tak.
Yang mana ya?
Ni topik rigid body.
Rigid body.
Kalau soalan tu ada rotation, formula dia apa?
Rotation. Oh, ID satu I rod tu. Ke I omega.
I nangis. Amat. Ada student ni buat mama nangis lah, Amat. Bukan. Aku. Okay. I omega. Tapi untuk soalan rigid body ni ada rotation tak? Tak ada kan? Untuk block B tak ada rotation kan? So you hanya consider formula apa? Formula ni saja. Ni tak payah. Kan? Dia bergantung kepada soalan. Last week kita buat banyak soalan pakai I omega. Tapi untuk soalan ni, you boleh buat soalan problem yang sama. Tapi dia hanya menggunakan 1/2 MV squared. Okay? Okay? Amirul?
Okay.
Ini untuk T. Kan? And then work. Apa work involved untuk block A? Soalan you tadi apa, Amirul? Determine. Determine
the displacement of block B.
Of block B. Starting from rest.
Starting from rest.
Contohnya lah. Kan, starting from rest lah. So, untuk soalan ni, kalau untuk block B, starting from rest, apa velocity dia? Kosong lah kan. So, T1 kosong. Tapi T2 adalah value, betul tak?
Ada.
IMV tu square. Ni lah yang kita nak cari. Bukanlah ni nak cari. V ni adalah. Tapi maksudnya soalan ni mungkin adalah V. Mungkin dia bagilah V 2 meter per second contohnya. Sebab sekarang ni you nak cari apa? You nak cari apa ni?
Nak cari
displacement. So displacement dia dekat formula mana? Formula work lah. Kan? Now, untuk soalan ni, blok, apa work yang ada? Bagi tahu saya, apa work yang ada?
Work daripada weight.
Daripada weight dengan tension of the
ah, Cable.
so you kenalah buat equation tu. Equation yang ada work. Due to weight and tension of the cable. Lepas tu you masukkan dalam formula. Formula mana? Formula ni. Faham tak? Boleh ke? Faham ke? Formula weight apa? Amirul? Iman?
Ya.
Apa formula weight? Due to weight?
Negatif W Y.
Delta Y. So W ni sama dengan mg, betul tak? Delta Y ni mana? Delta Y sama dengan Y2 minus
Y2 minus Y1.
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 Okay. Y2 adalah apa? Final. Y1 adalah initial. So kalau you ni adalah blok BU, dia naik ke atas, kan? Saya tak tahulah berapa height ni. Kena tahulah height ni berapa, faham tak? So you kena nak create question tu supaya you boleh solve problem tu, faham tak Amirul?
Okay, faham.
Baik,
Okay,
so,
kena cari tinggi dia lah.
Kena macam kalau nak cari apa tu displacement tu kena bagi nilai tinggi tu lah.
Tak, displacement tu nanti bila you dah calculate weight ni, work due to weight ni, dia mesti kena ada S dalam dia. Displacement dia S.
Okay.
S. Displacement dia S. Maksudnya kita punya formula work tu, work kan ada banyak. Satu due to weight, satu due to forces kan, satu due to spring. Kan semua formula work tu kita ada multiply S, jangan lupa multiply S. S ni apa? Displacement lah. Ingat tak? You kena buka balik nota tu Amirul Iman. You kena faham dan buat kan. Sampai dapat. I akan tanya ni hari Khamis nanti, next week. Sampai you dapat Amirul Iman. Dan untuk soalan yang sama, I nak you fahamkan macam mana nak guna impulse dan momentum juga. Okay, benda ni sangat penting dan akan bantu you all masa test dan masa projek. Benda ni bonus. Saya cakap ni, make sure you faham Amirul Iman. Macam mana untuk soalan macam ni nak implement work energy method, dan untuk soalan yang sama macam ni, macam mana you nak implement impulse and momentum. Okay? You kena tahu dan buat dan kena betul. You kena buka balik nota tu dan faham. Okay? Amirul Iman, I akan cari you balik hari Khamis ni untuk soalan ni. I nak you dapatkan this equation untuk satu soalan you ni determine the displacement of block B starting from rest, dan you reka lah soalan yang ada impulse, calculate the time. Tapi yang saya nak tahu ialah konsep macam mana you apply formula dengan tu. Value yang you nak apply tu tak kisahlah. Tekan calculator tu tak kisahlah. Saya nak konsep fundamental tu you faham. Okay, so kelas hari ni sangat penting untuk soalan basic ni you kena tahu macam mana nak relate menggunakan dua approach yang berbeza ini juga. Work energy dengan impulse and momentum. Okay, alright, dan benda ni boleh juga you jadikan sebagai you punya projek. Bukan projek saja, study untuk test juga. Okay, alright Amirul Iman, I akan cari you balik hari Khamis ni. Okay?
Okay.
Boleh. Okay, now kita kembali ke revision kit. So kalau kita kembali kepada revision kit, so soalan ni kita dah buat. So basically soalan ni you boleh cuba buat lah. Okay, so kalau you nak tahu soalan ni sama je macam soalan tadi. Nampak tak? Roman 1, based on your free body diagram, determine the equation of motion using Newton's second law. And then nombor 2, solve the equation using angular acceleration. Nombor 3, determine the angular velocity. Soalan ni sama je macam tadi. Tapi apa bezanya soalan dia? Ialah of course lah free body diagram dia mestilah berbeza. Kan? Blok A dengan blok B. And then yang akan membezakan kat sini sebab radius of pulley ni. So sekarang ni blok A akan ditarik oleh outer pulley. block B akan ditarik oleh kelas inner pulley. So bila you pakai formula A equals to R alpha, dia punya R berbeza untuk block A, R dia berbeza untuk block B. Faham tak kelas? Tapi soalan dia sama. Okay? Boleh tak? Boleh tak? Boleh tak?
Boleh.
Okay. Now, untuk soalan yang sama ni, boleh tak saya tanya soalan ni using work energy method, calculate the displacement of block A. Boleh tak? Macam soalan Amirul Iman tu. Boleh tak? Boleh kan?
Boleh.
Boleh.
Lepas tu boleh tak saya tambah using linear impulse and momentum, calculate the time taken for block B with a velocity of 2 meter per second. Boleh tak? Boleh kan? Boleh? Boleh tak? Boleh tak? Boleh
Boleh,
tak?
boleh.
Boleh. So maksudnya apa yang nak saya cakap, diagram ni, rigid body ni sama je tapi method yang berbeza. Kita boleh solve soalan sama untuk menggunakan Newton second law. Kita boleh solve problem yang sama kita boleh solve bukan problem yang sama, diagram yang sama menggunakan work energy method tapi nak calculate benda lain lah. And impulse and momentum method pun kita boleh pakai. Faham tak? Dan I nak you practice menggunakan dua method yang berbeza tu, macam mana nak solve problem yang jenis macam ni. Sebab kalau you tengok contoh yang ni dia guna Newton second law saja. Dia tak kata menggunakan work energy dengan menggunakan impulse. Reason saya nak you belajar cara tu sebab benda ni penting untuk you punya project. Sebab problem yang you nak solve tu, you kena kaitkan menggunakan 3 topik. Faham tak? Apa 3 topik tu? Semua topik you kena kaitkan kecuali topik vibration. Okay? You kena kaitkan 3 topik tu tapi menggunakan soalan diagram yang sama tapi you kena kaitkan menggunakan kinematics of rigid body. You kena guna plane motion of rigid body guna Newton second law, and plane motion of rigid body menggunakan work energy and impulse. You kena kaitkan benda tu bersama. Untuk satu diagram problem you. Okay, that's why saya nak you practice untuk soalan test ni, cuba buat benda yang sama tapi untuk impulse dengan untuk work and energy. Itulah motifnya. Okay, boleh tak? Okay, supaya nanti bila you buat project you nampak lah, you make sure you kaitkan 3 topik tu. Sebenarnya you punya projek bila you kaitkan 3 topik ni akan membantu you sangat untuk dapat markah yang bagus untuk projek dan you akan score you punya test. Okay. Alright. Okay. Alright. So I rasa soalan ni you boleh cuba buat sendiri. Okay. Now soalan ni pun sama. Nampak tak soalan ni? Write the equation. Okay, untuk soalan ni nampak? Calculate the total distance of block B moves before coming to rest. Untuk soalan ni sebenarnya method apa you boleh pakai? Dia tak cakap method apa. Sebenarnya you boleh je guna method topik kinematics of rigid body kan sebenarnya. Tapi kalau saya nak suruh you guna work energy, boleh ke tidak? You akan dapat jawapan yang sama, betul tak? Sebab dalam projek dia ada satu permakahan, you can solve the same problem using multiple solution. So kalau you nak solve problem ni menggunakan basic kinematic equation pun boleh. Tiba-tiba you tunjukkan you guna work energy pun you dapat yang sama. Kalau you berjaya tunjukkan tu, you boleh dapat markah bagus untuk projek. You faham tak? Soalan ni apa? Calculate the total distance that block B moves before coming to rest. Nah, soalan ni dia ada cakap tak method apa yang you patut pakai? Tak ada. Tapi bila you baca method ni, sebenarnya you mungkin boleh berfikir, sebenarnya kalau saya nak guna kinematics of rigid body punya equation tu, sebenarnya I boleh. Sebab I boleh dapat jawapan yang sama. Betul tak? Ingat tak jalan kerja topik kinematic of rigid body? Ingat ke tak? Ingat tak you all? Tengok, I pula nak belik-belik balik. Ingat tak? Apa dia kalau ingat? Now, untuk soalan ni, saya nak you try solve menggunakan work energy. Boleh tak? Boleh kan? Boleh tak? Soalan ni? Boleh tak? Kalau saya tanya you sekarang ni untuk guna soalan work energy, apa formula dia? Kelas ingat tak? Kelas, hello. Untuk soalan ni, kalau I ask you to solve this question, calculate the total distance that move before block B coming to rest ni, ini soalan ni sama tak macam soalan Amirul Iman tadi tu? Sama ke tidak? Amirul Iman, sama tak soalan you?
Sama.
Sama kan? So, tadi saya cakap untuk soalan ni, you kena guna work energy. Apa formula work energy tadi Amirul Iman? Ingat tak? Tadi bagi tahu saya tadi. T1, ingat tak?
T1.
Plus work equals to T2. Betul tak Amirul Iman?
Ya.
Okay. Since dia start coming from rest, T1 ni kosong. Betul tak? So, you kena cari T2. Apa formula T2 Amirul Iman? Kinetic energy tadi you dah bagi 1/2 mv square plus I apa?
I
Enggak.
I omega. Okay. So untuk soalan ni Amirul Iman, okay, untuk blok B, untuk Amirul Iman untuk blok B, untuk soalan ni, okay, cuba you tengok. Blok B dia boleh bergerak ke kiri ke kanan kan? Betul tak?
Ya.
So
Eh.
ada
Ya, kiri kanan.
dia boleh gerak ke kiri ke kanan kan? So maksudnya untuk blok B ni you bolehlah pakai formula untuk kinetic energy T2, maksudnya untuk T2 you akan pakai ni 1/2 mb VB squared, betul tak? Okay. Untuk blok B ni dia boleh rotate tak? Amirul Iman, blok B ni boleh rotate tak?
Rotate masuk medium. Boleh.
Macam mana
Tak
dia
boleh.
rotate?
Tak boleh.
Dia bergerak ke kiri ke
Bergerak kiri
kanan
ke
saja
kanan.
kan? Okay. So tu done. Okay, now blok A boleh buat apa? Ke kiri ke kanan ke atas ke bawah?
Atas bawah.
Atas bawah. So bila ke atas ke bawah, formula dia apa? Samalah. Allah. Tak. Kenapa hilang? Lagi sekali Kejap Lagi sekali Ni lupa ada square. Okay, maksudnya guys, okay, saya buat kat sini lah. Untuk blok B ni, dia punya kinetic energy adalah 1/2 mb VB square. Okay, tu faham Amirul Iman? Mana? Ambil. Untuk blok A, kinetic energy dia apa? M A VA square. Betul tak? Amirul Iman?
Ya.
Okay. Alright. Now, puli ni boleh ke kiri ke kanan ke atas ke bawah ke dia boleh rotate? Puli ni.
Dia boleh
Rotate.
pusing.
So apa kinetic energy untuk puli tu?
Dia
Ni Amirul Iman ni baca ni.
I omega.
Okay. Kenapalah degil sangat I punya ni. Sorry Dia macam sekejap nak betulkan ni sekejap. T sama dengan ni 1/2. Okay, so untuk ni kinetic energy dia apa? Kinetic energy dia. Kinetic energy dia. Dia ni dekil lah. T equals to kinetic energy dia apa? Ni TC Kenapa C? Sebab C I punya ni sekarang ni I nak merajuk dengan you, komputer ni pun nak merajuk dengan I. Tengok ni, dia bergerak ni. Kenapa dia bergerak? Okay. Apa TC? TC sama dengan I omega. Now, Amirul Iman, untuk formula I omega square ni ada 1/2 tak kat depan? Ke I omega saja?
Ada 1/2.
Ada 1/2. Okay. So nampak tak guys, untuk kinetic energy block B dia adalah 1/2 mvb squared saja. Untuk kinetic energy block A dia adalah 1/2 mava squared. Tapi untuk kinetic energy untuk puli C dia adalah 1/2 I omega squared. Nampak tak? Ini adalah semua kinetic energy untuk T2. Selepas, sebab apa? T1 sama dengan apa tadi? Sama dengan kosong. Faham tak? Okay, mungkin you dah nampak dah. So, boleh tak cuba fahamkan soalan ni pula? Nanti buat. Boleh? Boleh So, saya padam di balik. Okay, faham guys? Saya tak nak save ni. Nanti kan tersave pula ni. Okay, faham? Boleh tak? Pelan-pelan. So nanti boleh tak you all cuba buat soalan yang ni? Okay, baru you buat kinetic energy. Lepas tu you jangan lupa you kena buat apa? Work. Betul kan? Sebab formula dia untuk principle of work energy adalah kinetic energy initial campur work equals to kinetic energy after kan? So cuba jawab soalan ni. Alright, so saya X ni tak nak save. So basically inilah. So basically soalan ni tadi kita dah bincang secara general. I rasa kalau you all cuba dan buat, you all boleh tahu macam nak buat. Tapi dalam masa yang sama saya pesan banyak kali, cuba solve problem yang sama ni menggunakan work energy dengan impulse. Lepas tu soalan ni pun menarik untuk buat sebab soalan ni ada work energy tapi dia berbeza. Block B ni hanya ada kinetic energy due to translation. Bila due to translation, dia hanya formula dia adalah 1/2 mv squared. Tapi puli ni dia rotate, dia ada rotation. So rotation dia adalah 1/2 mv 1/2 I omega squared. Lepas tu block A ni pun dia hanya berlaku translation. Bila translation, formula dia apa Amirul Iman? Last kali nak dengar suara you. Amirul Iman, translation, kinetic energy, formula dia apa? Amirul Iman?
Kalau fixed axis
1/2
mvg square.
dah. Itu saja untuk blok A. Okay?
Itu
Sebab dia tak rotate. Dia hanya translation saja. Dia drag atas ke bawah saja. Dan B ke kiri ke kanan. Tapi yang puli ni dia boleh rotate. That's why formula puli tadi saya ada bagi 1/2 I omega squared. Tapi tak apa. Okay. That's why saya minta sangat-sangat you buat revision kit ni untuk practice. So nanti cuba buat soalan ni. Lepas tu cuba buat soalan ni. Lepas tu ni topik vibration nanti next week. Soalan ni kita dah buat tadi. Betul tak? Kita dah buat. Lepas tu soalan lain-lain ni boleh cubalah. Ni topik vibration. Ni simpan untuk next week. Ni topik vibration simpan untuk next week. Soalan ni dah boleh buat dah. Work energy method. Ni dah boleh buat dah. Okay. Alright. Okay. Dan yang lain-lain ni lah. Okay guys. So ada apa-apa soalan tak? So kita recap saja. So hari ni kelas penting sebab kita ada talk a little bit about project. So untuk kelas C2 tadi, yang kelas saya pagi tadi pukul 10, pukul 8 tadi setengah, saya minta sangat-sangatlah you dengar video ni. tapi sepatutnya kalau you tengah dengar sekarang, you dah tengok lah video ni dari pagi tadi. So sebenarnya ini explanation macam mana nak handle you punya project, nak bagi you ada idea sedikit. Lepas tu hari ni kita try to solve soalan final exam sebab tujuannya nak bagi momentum kat you untuk solve, untuk mulakan you punya revision kit, dan kedua nak bagi idea kat you macam mana untuk final exam, dan juga lastly nak bagi idea kat you last untuk macam mana you nak create you punya project menggunakan topik-topik tersebut lah. Topik yang ni Newton second law, dan tadi saya ada selit dengan Amirul Iman work energy dengan impulse and momentum. Okay, alright tak? Ada apa-apa soalan tak? Saya rasa apa yang you kena buat sekarang ni ialah practice dan work the problem and ask questions if you don't understand. Betul tak? Betul tak?
Betul.
Okay, good. Alright, so jangan segan-segan tanya soalan. So kalau ada apa-apa soalan tak? Kalau tak ada, saya stop recording lah. Okay, saya stop recording. Saya akan share dekat dalam ni lah.